In the last video, we went over the properties or rules of exponents, and so this one we're just going to put them into practice. We're just going to practice. Now, all of these, you can check your answer by using the calculator. The only part, the times you can't, is if the answer comes out to an ugly fraction or if you have a variable in it. All right, so variables where we kind of want to use these rules. But I'm going to do the first few examples, cases where if you wanted to, you could technically solve this with the calculator. All right, so the first example would be 16 raised to the 3/4. Right, so the first thing I'm going to do is I'm going to split it into 16 raised to the 1/4 cubed, which remember 1/4 is the fourth root of 16, and then cubed. Well, 16 is a perfect fourth. The fourth root of 16 is 2. Right? 2 raised to the fourth is 16. Right, so this is 2, and then don't forget there's the cube on the outside, and 2 cubed is 8. If you type in 16 raised to the 3/4, it will give you out A, and this is the easiest way to, this is the easiest path to simplify. It's easiest to take the fourth root of 16, which is 2, and then cube 2, which will give you 8. All right, another example. 4 raised to the 1/3 divided by 4 raised to the 5/6. So remember, when we got division in the same base, right? But 4 is the same base. It's 4 raised to the 1/3 minus 5/6. Which, if I was solving this by hand, all right, you can use your calculator, but if I was solving that by hand, I have to make that a 6. So I've got to multiply by 2 over 2 to get to the 6. So this is 4 raised to the 2/3 minus 5, not 2/3, 2/6 minus 5/6. And so that comes out 4 raised to the negative 3/6, which is 4 to the negative 1/2, which, like I said, you get to use your calculator, so you could have gotten there by using your calculator, but there's exactly how you do it if you didn't have a calculator. And so I get 4 raised to the negative 1/2. So remember, 4 raised to the negative 1/2 really means 1 over 4 raised to the 1/2, which is 1 over the square root of 4, which I know what the square root of 4 is. And so the answer after all of that is 1/2. All right, 4 to the 1/3 divided by 4 to the 5/6. I'm solving it by hand. Comes out to that simplified expression. Like I said, you could check your answer if you type this in the calculator. It should come out 1/2. All right, next example. 5 raised to the 3/4. Taking that whole thing raised to the 2/3. So remember, when I take a power raised to a power, you multiply, and so it's going to be 5 raised to the 3/4 times 2/3, which that simplifies into the 3 is reduced to 1, 2 goes into 4 twice, so 5 raised to the 1/2, or exactly the square root of 5. Right? Either one of those are equivalent expressions. And I'm going to leave it exactly, square root of 5, no rounding. All right, next example. Negative 125 raised to the negative 4/3. Alright, so negative 4/3. So first of all, I'm going to take care of the negatives. So I'm going to move that down. Negative 125 raised to positive 4/3, all in the denominator, which can be rewritten as 1 over, again, you could probably skip a few of these, but I'm going to do them in all of the steps. So remember, I can rewrite this as the negative 1 over 2, negative 125 to the 1/3 raised to the 4th degree, right? I can split the 4 and the 3rd, which can be rewritten as 1 over the negative cube root of 125, and then that to the 4th power. Cube roots can have negatives, so I'm fine, right? That's a square roots and even powered roots I can't. So the cube root I can. So I can find the cube root of negative 125. And so what value is the perfect cube of 125? Well, that's 5, and it just has to be a negative 5. So this simplifies into negative 5 raised to the 4th still. Don't forget I still have this raised to the 4th on the outside. And so 1 over negative 5 raised to the 4th simplifies into 5. And that one you would probably need your calculator for. Make sure you're careful. It's negative 5 raised to the 4, which is an even powered. If you're not careful there and you don't put parentheses around the negative 5, it'll give you the wrong answer. It's 1 over positive 625. That's exactly what that simplifies down to be. So negative 125 raised to the negative 4/3 is equal to the fraction 1 over 625. Right, now, like I said, all of these you could have solved with your calculator, right? You didn't have to necessarily solve them by hand. The case where you have to use this method would be if you have a variable inside. So if I have something like x raised to the 4/5, right? If I want to write x raised to the 4/5 times x raised to the 3/2, right? Well, that simplifies to x raised, I multiply 4/5 times 3/2, which the only thing that simplifies is the 2, so I get x raised to the 6/5. Or if I have something like the square root of x squared divided by x to the 3rd, well, that simplifies if I rewrite it. That one I'm going to do to the 5th. There we go. Square root of x to the 5th, because that would have simplified. Square root of x to the 5th. Well, I can rewrite that as the fractional power 5/2, right? The square root is the 1/2 power, and I can rewrite that the 5/2 divided by x cubed, and then I use my division property, which is x to the 5/2 minus 3, which again, you can use your calculator, but I can use the fact that I can multiply this by 2/2. So I get x to the 5/2 minus 6/2, and so it's going to come out x to the negative 1/2. And so 1 over the square root of x. 1 over x to the 1/2, which is, so this simplifies to 1 over square root of x, or x to the 1/2. All right, and so that's where you have to kind of use these properties to sort of to simplify expressions. All right, so those are this property in use. So those using the property, square root properties, in order to simplify expressions. Actually, I want to do a couple more examples. So I'm gonna, before I get to the next set, there's actually, because there's one in this like the book, and or on the website, on the My Math Lab examples, and so I want to make sure I do this. All right, just so that you've seen it. All right, so there is one like this on the homework in the book. They ask you to simplify a complex expression like this: the square root of the square root of y to the 4th times y. All right, and then they ask you to simplify it. And so really what it comes down to is switch all my roots to my fractional powers and simplify. All right, so outside, that's the 1/2 power. Here, it's y to the 4th raised to the 1/2, right? Times y. And remember, if it's just y, it's understood to be 1. All right, so simplify the y to the 4th to the 1/2 first. Well, that simplifies into 4 times 1/2, which is just y squared, times y to the 1/2 power. And so remember, this is understood to be 1, and when I multiply, I add, so it's y cubed to the 1/2, and that simplifies to y to the 3/2 power. All right, so just as an example of simplifying something that looks at the start fairly complex. But what you have to do is you have to switch to the fractional powers and then use your rules. Multiply when you're supposed to multiply, add when you're supposed to add, subtract when you're supposed to subtract. All right, so simplifying expressions. All right, so we'll stop there. There will be a few of those on your homework, so make sure you do understand your rules of exponents, where you add, multiply, subtract,